This is a nice problem for learning how to categorize unseen triangles as either a regular law of sines, maybe a more ambiguous law of sines, like it could be two triangles, or a third case, which is the law of cosines. And what I want to do is take you through a strategy that I use when looking at these things. Question number 1. Are there two angles? Because if there are two angles, this is going to be law of sines, just every time. Okay, let me get this out of here, and we'll just talk about these one by one. So look for any of these setups that are two angles. Here's one. Okay, that means this one is law of sines. Do we have any other angles? Here's one. Another double angle, that's going to be law of sines. And we've talked about the reasons for these in past videos, so I'm not going to dwell on those too much. But if you have two angles, you can always find a third, and that always produces a matching pair. Okay, so there's no need for a law of cosines. Next question I'm going to ask. Do we have no matching pairs? So no matched pairs of angles and sides. And if you have no matched pairs, that's going to be law of cosines. Okay, so let's see. Do we have no matched pairs? What am I looking for? Here's one. Okay, there's not even any angles in that. It's just three sides. And they're all different sides, obviously. Here's another one. Law of cosines right there. Angle C, sides A and B. And what else do we have here? Do we have any more? Oh, there's one at the end. Law of cosines right there. Okay, so having been through those, now I'm going to ask another question. Do we have a matched pair? And I'm not looking for angle, side. We've already ruled those out in the green color. I'm looking for a matched pair where you have a side angle and not ambiguous. Okay, so there's a bunch of different reasons that would lead to not ambiguous. I'll review those as we find them. So if I look at the first one on the list over here, okay, I have a pair, see the side A and angle A, and the question is that side short? We better make a fourth category because I think we just found something. Fourth category is you have a matched pair, it's side angle, and it is the dreaded ambiguous case. Okay, there's two triangles possible as a result. All right, so this first one is ambiguous, and the reason I know just by looking at it is when I look at the matched side, that's short compared to the other side. So this is ambiguous right here. So law of sines, ambiguous case. That one's going to be a pain in the neck to solve, but we're not going to do that here. Next one, let's see. I've got a pair of matching sides right here in this one. And take a look at this. The side that's matched is long. It's longer than the other side. So that's just going to be a regular law of sines. And likewise in this one down here. I've got a matched pair of sides, and that right there is a long side. In fact, I skipped over something in this first one. I want to go back to this last one I just did right here. There's an even better giveaway, much more important giveaway, actually. Maybe you can pause the video, see if you can catch it. What did I miss when I went over that one? Okay, it's this angle right here. That angle is obtuse. When you have an obtuse angle, it is always not ambiguous. There's only one possible solution for that triangle. Okay, so think of these different scenarios as you're looking at triangles. I think numbers 3 and 4 are the most interesting because these are cases where you have an obtuse angle shown to you. You're given an obtuse angle, or where the matched side is long. Okay, that's a regular side angle law of sines problem. Whereas this side angle ambiguous case, that's only one scenario. That's an acute angle given, and where the matched side is short. Okay, that's when you have a lot of work cut out for you. But I think more enjoyable is when you find something where there's just no matched pairs, for example, right? That's a law of cosines. That's a little fresh. We haven't seen those before very much, and we'll get some more practice going forward.